Alrighty, so application problems with trig. In this example, I'll show you what we are aiming for. Is it this one? No. This preview gun. There. Okay, I won't be able to show you the whole thing all at once, but we'll just make a bit of a start. So, by the way, a lot of these, like there's a bunch of questions in the textbook, and I will put textbook references up on your learning schedule. But there's also a bit of, there's also going to be, I'm going to put a few more resources onto Google Classroom as well. And this particular problem and the ones that are in this document all come from the IB. So it's a similar standard of problem, but just that they are just worded a bit different to give you a bit more breadth in what you might see in the textbook, I suppose, because they can really throw anything at you for this. So anyway, here it is. The following diagram shows a ball attached to the end of a spring which is suspended from a ceiling. And there's a lovely picture. And there's the rest of it. There you go. Ceiling, spring, ball on the end. There's a height from the ground up to the ball. That's the main thing to look at there. And it says the height h meters of the ball above the ground at time t seconds after being released can be modeled by the function h of t equals, and then we've got it there. So I'm going to write it onto my iPad right now. You can write it in as well, because then I'll be flipping backwards and forwards. I'll give you a chance to write that yourself. Yeah, so when it comes to application problems, it's a bit, it's hard to give you a one-size-fits-all approach to application problems. Quite frequently, they want you to draw the graph, or they're giving you the graph and you have to take information from it like we've just been doing. Sometimes they don't. When you look at the questions here, and I'll be flicking backwards and forwards over and over again, so just be mindful of that. 1A is find the height of the ball above the ground when it is released. 1B, find the minimum height. 1C, show that the ball takes 2 seconds to return to its initial height. And 1D, for the first 2 seconds of its motion, determine the amount of time, blah, blah, blah. None of those require you to draw a graph. And so it wouldn't be silly for you to not draw a graph, I suppose, and just use your understanding of how functions work in order to solve this problem. But it's actually a fairly straightforward graph to draw. If you have a look at the function itself, can you sort of see this function? The only thing that would make it more complicated, I think, is if it had a phase shift. And there's no phase shift there, so it's actually a pretty straightforward draw, I think. So I think personally, I'd be looking in that and going, I think I can draw that pretty easily. So I might do that and see where it takes me. So that's how I'm going to approach it. But, you know, you might look at that and go, well, I know how to find the height of the ball, set t equal to 0 and solve. I know how to find the minimum height. I just set cos of pi on t to -1 and solve, and so on. So you could absolutely do this just from a pure analytical, I know how these functions work approach. But I'm going to start with a graph draw. But like I said, your mileage varies depending on the problem. Hopefully that's enough time for you to at least get as far as me here where I've got the function down. So I'm going, for this particular problem, I'm going, yeah, I think I can draw that okay. I think I can draw it okay. So if I have a period of 2 pi normally for cosine divided by pi, I get a period of 2. And so if I draw my graph, do you want me to close the window, or is that noise not bothering anyone? No, don't care. Cool. The sounds of children playing. Oh, it's lovely. So I can see I've got a period of 2. So I can go straight into, well, there's 2. There's 1 in the middle. There's a half here. There's 1.5 here. So I'm just doing my usual splits into quarters. And then I know that the vertical translation is my new center. So I'll pop my center line in here. So that's what, 1.8. And then I know that I've got an amplitude of 0.4. So I'm going to go up to 2.2 and down to 1.4. Plonk in my guidelines here. And as I'm doing it, it's a bit slow, but the idea is that you would do this pretty quickly. Like because I'm talking it through, I'm being pretty slow with it. But this is really something that would take, less than a minute to draw if I was doing it for realsies. Then I start here, go to the next quarter here, finish down here, go up to here, and then up to 2. And then I'll just draw my quarters in. And then my graph's done pretty quickly. So there's my graph done. And I've already looked at my questions already and I've gone, yeah, I can see how my graph might help me answer these a little bit faster. So I've done that. And then I'm going to switch. I'm going to zoom out now so you can see my working out at the same time. And this is where I'm just going to have to do a little bit of switching between screens to get each of those questions there. So the first question, part A, was find the height. So it was find the height when it is released. So the interpretation there is being aware of what kind of language when it is released would mean. What does that mean in the context of the problem? Yep, when t equals 0, when time is 0. So we can either do a substitution or we can look at our graph and go, oh, I can see it's 2.2 at the y-axis. So you can go at t equals 0, h of t is equal to 2.2 meters, and we're done. Make sure you put your units in, otherwise you might get pinged half a mark here and there. Is that okay? Now, just to do it analytically, I'll try not to be too slow with this, but if I could have just gone h of 0 equals if I hadn't done the graph, cos of pi multiplied by 0 plus 1.8, then you can go, well, the cos of pi times 0 is the cos of 0, which is 1. That's going to be 0.4 plus 1.8, which equals 2.2. So you could certainly do it analytically without drawing a graph. I feel like the graph gives me a lot of information quickly if you're confident enough to draw it pretty quickly and accurately to start with. But yeah, you could do it analytically. And it's the same thing for all of these. I won't do the analytical approach for all of them though. Part B, find the minimum height of the ball above the ground. Find the minimum height. So again, because I've got my graph already, I can pretty well much just go, I can see what the minimum height is. So I've got the bottom of my graph right here. It's at 1.4. I did all that work before. Now it's paying off. Done. Okay, no more calculations need to be done. Now, if you're doing it analytically, I'm not going to write this down, but just verbalize it. If I was doing it analytically, I'd be going, well, I know my cosine function will be a minimum, where the minimum value for cosine in general is -1. Okay, doesn't matter about the angle. The output will be a minimum -1. So I'd have 0.4 times -1, which is -0.4 plus 1.8 is 1.4. So again, you can do it analytically. C, show that the ball takes 2 periods to return to its initial height. Okay, I've just summarised that on the on AirSketch. If you haven't quite got it, it'll be there as well. show that the ball takes 2 seconds to return to its initial height. Then you would say from graph, shown on graph. The period, the time it takes to return to its original height as the period, is equal to 2 pi on pi, which equals 2. Then on graph. Okay. D. Last part. For the first 2 seconds of its motion, okay, first 2 seconds means from 0 to 2. That's one cycle, one period. Determine the amount of time that the ball is less than 1.8 plus 0.2 root 2 meters above the ground. Now, again, for the analytically minded, you can probably look at that and go, oh, yeah, I see what I need to do, and away you go. For those of us who aren't as gifted as you, I think this is where drawing the graph really comes into its own with 1D, in that I'll just use a different color again so we can see it. I have to find when it's less than 1.8 plus 0.2 root 2. I don't know what 0.2 root 2 is, but I know what 1.8 is, because 1.8 is that middle that I had there. So I know that 1.8 plus 0.2 of root 2 must be somewhere here. So that's 1.8 plus 0.2 root 2, which is h. That's my line there. So what I can see is that this is where it would be underneath that. So if I can work out what that point is and work out what that point is, then the distance between here and here will give me the time that it's underneath that particular line. So having that graph allows me to visualize what I'm doing. M. I don't know. Can I just suggest to you that it's definitely going to be above 1.8, and it's definitely, well, I can't say it's definitely going to be above 2.2. If it ends up being above 2.2, then I'm going to get an error with my function. And I'm assuming that the problem solvers, the question writers aren't going to give me an impossible question, but even if they did, I could handle it. I'd get an error out of my cosine function, and I'd be going, therefore, all of the time, it'll be under that. Yeah, good question. Thank you. Question, Charlie? Hamish, do you have a question? Okay, just chatting then. It's a shame. Right, so now that we've got that, we can sort of get a sense of where we're headed. I need to find that point of intersection and that point of intersection. And we know already how to solve points of intersection, right? We set both of those lines equal to each other and solve. In other words, we do the following. 0.4 cos of pi t, plus 1.8 is equal to 1.8 plus 0.2 root 2 over the interval 0, 2. And you may be going, oh, what do I do from here? Right? It's all 0.8s and decimals and square roots and stuff like that. But, you know, the question setters aren't numpties. If this was in the calculator section, maybe I just put it into my GDC. But it actually is a non-calculator question. It's not too bad. Subtract 1.8 from both sides. You could do this in fewer steps if you are feeling keen to, and you get 0.4 cos pi t equals 0.2 root 2. Divide both sides by 0.4, and I get cos of pi t is equal to 0.2 root 2 over 0.4, and 0.2 goes into 0.4 twice. And so we get root 2 on 2. Cos of pi t equals root 2 on 2. Ah, that's good. Root 2 on 2 is one of our exact values. So we're good to go from here, I think. Now, again, I'll continue solving the problem. Feel free to get ahead of me. I know that there are people here in this room, having just marked all your assignments, that do their own method from a different teacher. It's not quite as it's a little bit more shortcutty than my method, but if you can get them right all the time, you do you, right? That's absolutely fine. You come into this course with knowledge of how to do things, use it. My way, I like my way because it breaks it down into small steps at a time. So I'm going to do that now, but again, try and get ahead of me and get your answer in. So I'm basically going to do a domain adjustment. So let theta, I could have used x, but I've used theta. Let theta equals pi t. Then we have cosine of theta is equal to root 2 on 2. And then the adjusted domain is 0 times pi, which is 0, and 2 times pi, which is 2 pi. That's pretty good now. It's a pretty simple question by now, how to solve that one. So I'll go ahead with it and do it nice and fast. Cos theta hat is equal to, ignoring the sign, but there isn't one, is equal to root 2 on 2. Gives us an acute or base angle of pi on 4. Excellent, 45 degrees. Nice work there. And then away we go with working out our unit circle possibilities. We've got positive root 2 on 2, so it's going to be cosine is positive in the first and fourth quadrant, and theta hat sits in there. And so that makes theta equal to pi on 4, or it's equal to 7 pi on 4, which is 8 pi on 4 less 1 pi on 4. And that means that that is equal to pi t. So I divide through by pi to get t is equal to 1/4 or 7/4. Okay, so there are my solutions for t. So going back to my diagram here, I'm saying that this is 7/4 of a second here. Yeah, why not? 7/4 of a second here, 1 3/4 of a second. And this is a quarter of a second here. So that's what I've got, a quarter of a second and 1 3/4 of a second. And so my answer is not 1/4 and 7/4. It says how long does it stay underneath that height. So the answer, I hope you can see. Therefore, for time, under 1.8 plus 0.2 root 2, 0.2 root 2 meters, we have 7/4 minus 1/4, which equals 6/4, i.e. 1.5 seconds. You could say 3/2 seconds as well. Either would work. And that's basically it, right? So just to summarize, sometimes but not always, drawing a graph to start with might really aid your thinking all the way through. You may find the graph is too hard to graph to start with because of phase shifts and stuff. It's up to you to decide whether the effort is worth it. You know, if it's worth 3 marks, maybe spending 2.5 minutes drawing a graph is too much for you. You know what I mean? So just, you've got to think analytically about how much time you've got to do with it, and then make a decision whether drawing a graph might be useful or not. And don't be afraid to change your mind. You might get to A, B, and C, and then go to D and go, I've got no idea what this is. I'm going to go draw it now and then make sense of it then. Or never draw it at all because you get how to do it. That's absolutely fine. But once you've done the graph or not, you then answer each question, and always, 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 as with every application problem, make sure you've answered the question. Find the height when it is released. The answer is not 2.2, it's 2.2 meters. Blah, 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 blah for each of these. For part D, find the difference. Find how long it takes, how long it is below 1.8 plus 0.2 root 2 in height. Don't give me an answer of 1/4 and 7/4. Give me an answer of 1.5 seconds or 3/2 seconds. Answer the question. Always answer the question. Speaking of answering questions, can I answer any of yours? Yep. Right. So in my methodology, in everyone's methodology, to be honest, but it's just the way I express it. When you've got your trig function built up here, and in this case it's root 2 on 2, but it might be minus root 2 on 2, the first thing you do is you identify the acute or base angle. It's the angle that is between the x-axis and the unit line. So that's always an acute angle. And so it's not, I didn't make it up myself, this particular way of doing it. So cos of theta hat refers to the base angle. So the base, if cos of the base angle is root 2 on 2, that would make the base angle pi on 4. By identifying the base angle, I know how much I'm going to be adding to 0, or in the case of this one here, how much I'm taking away from 2 pi. This one here, this represents any of the angles that would give me a value of root 2 on 2 between 0 and 2 pi. So I didn't write this in, Hamish, but it refers to this angle here, which is the same as theta hat, but it also refers to this angle here. Yeah, awesome. It's always good to get that clarity happening, Hamish. Really appreciate it. Any other questions? If you cos pi t, you can, as long as you adjust the domain. The original domain, which I've accidentally put in as an x there, the original domain is between 0 and 2. If you solved it for pi t, you would only get one of those solutions. So what some people do is they don't do a substitution like this, and what they do is they do the adjusted domain and say, therefore, pi t is a member of 0 to 2 pi. But you do have to do the domain adjustment. If you don't do the domain adjustment, you will not get all of the possible solutions. But whether you do a substitution to theta, or whether you just leave it as pi t and imagine that as a single object that you continue through, that's fine. Does that answer your question or not? If you try to do the domain over 0t with just pi t, you will not get all of the solutions. You just won't. We can look at that personally together if you like, Tian, because otherwise I'm just retreading what we've talked about in previous lessons. Anything else? So you always have to do a domain adjustment if there is some sort of period change. Yep. Or phase shift. Okay, that'll do for the video.